So when this happens, well, essentially, how do I go from here to here? Well, all I have to do is add another pi over 3. So essentially what's happening is sine of 7 pi over 3, another way to write that is sine of 6 pi over 3 plus another pi over 3. Now, since this is technically just going around the circle, I'm basically ending where I started from, right? So I go all the way around, I start here, now I just add, so I'm essentially adding 0 to this, which ends up being over here, which is just pi over 3. So the whole thing now is, well, this ends up being, what is sine of pi over 3? And that's actually your answer. Okay, so going back to unit circle, we find out what sine pi over 3 is, and that's our complete answer there. Okay, and that's how we're going to do all these. So believe it or not, it's pretty interesting stuff. The same thing applies with cosine. So cosine, again, just using this portion. So going that portion, and again, now we want cosine of 9 pi over 4. Well, another way to write 9 pi over 4 is, well, that's cosine of, well, it goes around two whole portions. That's going to be 8 pi over 4. That's 2 pi, right? Essentially going around the whole unit circle plus an additional pi over 4. So we're going around the whole unit circle once, and then we're stopping at pi over 4. So this whole thing ends up being what is cosine of pi over 4. Because remember, since we're going to unit circle all the way just over and over and over again, we're just going to be passing the same thing just like a flagrant portion. And again, now we just go into which each one individually is going to be. So if we go back, sine of pi over 3 is going to give us, let's see, what is it? Radical 3 over 2. And then cosine of pi over 4 is going to give us radical 2 over 2. And that's how we're going to do these type of portions when it comes to it. We're going to figure out what's pretty much the remainder of it, right, when it comes to it, and then what's left over, and when it comes to things like that, and just go from the unit circle. Now here is actually the main properties of them. So notice that's exactly what we did. So the k is an arbitrary value, right? So it's how many times you're going around the complete unit circle in this case. And now notice what you care about is literally the remainder of the portion, or what's being added onto it. So we can really cancel those out essentially. Now the only thing you got to be careful of is these two here, because all the other ones have a period of 2 pi. Therefore, but tangent and cotangent only have a period of pi. So that's the only thing you got to be really careful of when it comes to it, and things like that. And we'll do a real example, especially for C and D as well. So using these properties, what we want to do is figure out find the exact value using these, again, not using a calculator, right? Using the actual trig functions. So we can do the same thing we did above. So this is 19 pi over 4. So again, another way to write 19 pi over 4 is, well, how much is it going evenly? So, or in other words, how many times at the revolution are we actually going around and around and around? So if we go around and around, so it goes into it, I believe, 16 evenly, right? When it comes to, and what's left over? Well, what's left over is 3 pi over 4, right? That's the only way to get the 19 pi when we add it. Now remember, this is going around actually 4 times. Yeah, 4 times, going around 4 times, and ending up at this portion here. So this becomes sine of 3 pi over 4, and that's our final answer, or whatever sine 3 pi sine over 4 is. So you go back to our unit circle. The sine of it is radical 2 over 2. We get a new 1. And there's your answer. Okay. So let's try B now. So cosine of 7 pi. So cosine of 7 pi, again, can be written as 6 pi plus pi. Again, according to how we want to break it down, right? So again, 6 pi means just going 3 times around the unit circle, right? Here's 2 pi, 4 pi, 6 pi, and then what's remainder going back to pi. So essentially, this is the same thing as writing what cosine of pi is. And that's going to be just -1, right? Because that's the x component. Okay. So let's try the tangent one. It's a little tricky because tangent is only pi revolutions. So we want to figure out what tangent of 5 pi over 4 is going to be. Okay. So using tangent meaning just pi, so this is the same thing as writing tangent of 4 pi over 4 plus another pi over 4. Because again, right, this gives you 1 pi, not 2 pi, like the other ones. Okay. So once we do that, this is the same thing as finding tangent of pi over 4. Well, tangent of pi over 4 is radical 2 divided by 2 over radical 2 divided by 2, or just 1. Okay. All right, so why don't you guys try D and E there. So I'll give it a quick pause. So 3, 2, 1, pause. Okay. All right, so hopefully you guys try them out. Let's do them together now. Okay. All right, so same as tangent, right? Cotangent also has a period of pi. So when it comes to this, the same thing as now writing cotangent. We're going pi, so this goes into, let's see, what? 9 pi over 3 with a remainder of pi over 3 revolutions, right? So it goes around 3 different times. Okay. So therefore, this becomes whatever cotangent of pi over 3 is. Oh, cotangent of pi over 3. So since this cotangent is x over y, so in this case it's going to be 1/2 over radical 3 over 2. And I believe if you simplify this, I think you just get radical 3 when it comes to it. Okay. No, actually 1 over radical 3. There you go. 1 over radical 3. Okay. And then for E, it is cosecant of 9 pi over 2. So again, this is the same thing as cosecant of 8 pi over 2 plus another pi over 2, make it 9. So since this is going around over and over and 4 times, that goes nothing, and what we care about is what's the remainder of just the 2 pi. All right, so the secant is 1 over y, so for pi over 2, so 1 over 1 is just 1. Okay. So that's how we use these properties to find the exact values when we're just going around and around revolutions when it comes to the unit circle. Okay, these kind of stuff. Now, the next type of this section is the fundamental identities. Okay, so in other words, finding the exact values of the trig expressions. Okay, so when it comes to these trig expressions, is well, using the same template, right? Where these are in radians, you do the exact same thing when it comes to degrees. We use the exact same process. So it's just a little trick proportions when it comes to it. It's nothing too big a deal when things like that. But again, now it's a trick question now using degrees instead of the radians itself, or vice versa. So a couple of these, right? Now, when it comes to these type of identities, most of the time we're going to be using these special properties here. So we're going to use the Pythagorean identities that help us out. Reciprocal identities, we talked about these already, essentially. And so mostly the Pythagorean identities is going to help us out for these sections. But again, these will also help us out when it comes to these ones. Okay. So why don't we try these out? So we're going to find the exact value. So in other words, no using actual calculators. We have to do this the old-fashioned way, right, by hand. Okay. So it's actually not that bad, right? Knowing the process. So tangent we know is sine over cosine. So this is sine of 20 degrees over cosine of 20 degrees, and then minus that. Now notice that gives you exactly 0, right? Because we cancel each other out. And that's how we're going to do these sections. It's a straight out simplification based on what we have. Okay. So let's try B. All right, so this is sine square root of pi over 12 plus, now this is a trick question, right? What is 1 over secant squared? Well, if we go back, we know that secant is 1 over cosine. So if you square it, that's going to be 1 over cosine squared. And if it's 1 over this, it's actually reciprocal, which gives you cosine squared of pi over 12. Now, if we know this very special identity, right? Sine squared plus cosine squared equals exactly 1, and it doesn't matter what the theta is going to be. So this ends up being a nice 1. Okay, so try these out. So C, D, and E using roughly the same template we did here. Okay, so give you a quick pause. 3, 2, 1, pause, and try them out. Okay, so hopefully you guys tried them. Let's try these ones. C is a little tricky because it's a tangent, right, when it comes to it. So, fun fact, right? Tangent 200 degrees. Now, going back to our periodic properties, right? Tangent has a revolution of pi, or in degrees, it's 180. So if we go back over here, you can see, right? Pi is the same thing as 180. So in radians and in degrees, it's going to be, instead of 200 degrees, I can rewrite tangent as 180 plus 20 degrees, right? That gives you the 200 degrees total. Well, this is pi. So therefore, according to our properties, just like we did here, right, this is going to be simply just simplified down to tangent of 20 degrees. Okay. So therefore, I can rewrite this whole thing as just that now. So now we have tangent 20 degrees times cotangent of 20 degrees. Okay. Well, what's another way to write cotangent? It's 1 over tangent. And that ends up being just exactly 1, right? Okay, so let's try the rest of them. So this should give you a little precursor to what we're going to do here itself, right? Okay, so this is tangent squared of 67 degrees minus 1 over cosine squared of 67 degrees. Well, since we have the tangent and the cosine here, let's go back to what we have. Well, we do know that 1 over cosine is secant. So since it's squared, this whole portion is going to be tangent square root of 67 minus secant square root of 67 degrees, right? And going to our properties here, we have one very special one here. So I can rewrite this, right? Let's say I want to solve for tangent, for instance. If I want to solve for tangent, therefore I subtract the 1. So I have secant squared minus 1. So if we go back over here, I can rewrite this as secant squared over here. And now this is going to be secant square root of 67 minus 1, like that. Now notice the secants cancel, and we get negative 1 as our answer. Okay. And now the last one over here, well, another way to write those as well, right? Going back to our portion. That's 1 over sine, so if it's 1 over, it's going to be just sine. And same thing applies here for secant. Since it's 1 over secant, it's going to just be cosine itself. But since there's a 2 in front, this is going to be 2 sine of 7 pi over 8 plus 2 cosine 7 pi over 8. Now if we factor out a 2, we can now get this. And again, we talked about this earlier. Sine squared plus cosine squared gives you 1. So this is 2 times 1, or a nice 2. So a little practice when it comes to those. Next video, we'll talk about, well, what happens when we go a little bit backwards, going back to those triangles and stuff, giving very little information itself. Okay.